Well, good afternoon, folks, or at least most folks. I'm sure there's some folks out on the West Coast where it's still morning, but I'd like to say thanks to everybody for joining us for today's webinar. Today we will be covering an introduction to the Asterisk REST interface, ARI, the newest in a long line of interfaces that have been added to Asterisk to make it more capable, more powerful, more easily integrated with other solutions. So we will get rolling here in just a couple of minutes just to kind of go over the basics. First of all, there's a question and answer system in this. This is a rather long presentation. I'm not sure that we'll be able to answer too many questions, if any at all. We'll try. So if you have questions, please feel free to post them, and we'll do our best to answer the most common of those in a follow-up email after the presentation goes out. Also, we're going to be taking a number of polls as we go through. We've got a couple at the beginning to kind of get a feel for who our audience is, and then a couple at the end to kind of see what sort of follow-up we need to do. So please do your best to answer those as we come up to them. I think first things first, I'm going to introduce our host, the company that I work for, Digium, which is the original creator of Asterisk and the sponsor of the ongoing project. Asterisk is now 15 years old, and for the last 15 years, Digium has been making all of the essentials for Asterisk. So interface cards, gateways, telephones, of course. Digium provides a line of Asterisk-specific telephones. We also provide support, training, and host the AstriCon conference. So while I have a moment, I'll mention that AstriCon is coming up this fall. It'll be the last week of September in Glendale, Arizona. So if you happen to have the opportunity, it's a great place to go to meet other Asterisk developers. There are usually many presentations on technical topics, including ARI, so it's a good place to learn, a good place to sort of network with industry insiders, to meet some of the people that actually create Asterisk, and to share your opinion on where Asterisk should go in the future. So if you have the opportunity, please join us in Glendale this fall. So I'm going to lead off with our first poll question to kind of get an idea of who all is in the audience and at what level I need to be speaking. I'd like you to let me know what level of experience you have with Asterisk. If you're completely new to Asterisk, let us know, and we'll try and fill in some of the Asterisk-specific bits of information. I'd also recommend, if you're completely new to Asterisk, there are other presentations you might want to watch to kind of catch up. If you have some experience with Asterisk, that's great. If you've been using Asterisk by itself, or perhaps through a distro, something with free PBX on the front end and Asterisk under the hood, sort of be in the middle. And if you have been developing applications on Asterisk, coding Diaplan, doing AGI apps and things like that, then please pick that last option. And so we'll give you just a couple more seconds and then click on and we'll see who we have. 3, 2, 1. Okay, here we go. Now, it looks like we have a few people who are very new to Asterisk. We have about half of the folks here with some experience, and we have the remainder who have a great deal of experience, so some number of experts. So that kind of brings us to our next question, which is asking you to describe how you're using Asterisk or what you're doing with it. If you are using it in a business for your own business's communications, either as a PBX or an ACD or something else, please pick the first option. If you build solutions for other people, if you're an integrator or a consultant, please pick the second option. If you build a product out of Asterisk, if Asterisk is sort of ensconced inside of your solution, please pick the third option. And if you use Asterisk at home for home automation or for your own home phone system, please pick the last option there. And 3, 2, 1. Okay. Looks like we have a preponderance of integrators and consultants, which isn't surprising. ARI is an ideal technology for people who are building Asterisk-based solutions. So I thank you guys for participating there, and again, we'll hit you up for a couple more answers as we get close to the end. In the meantime, I should take just a second to introduce myself. I am the marketing director for developer products at Digium, and while I am a marketer at the moment, I am also a longtime Asterisk user and have contributed to the project in some ways. And so I'm not completely behind the curve when it comes to technology, but I will say that it's kind of fun to be able to describe ARI as a technology that's so easy even a marketing guy can do it. So, and I will be taking you through over the next, say, 55 minutes, a review of ARI. So we're going to talk about the historic interfaces of Asterisk, going back across the 15 years that Asterisk has been in use, and how ARI is a different kind of interface and allows you to do different sorts of things than you can with any of those existing or legacy interfaces. We'll talk about the basics of ARI, the technologies that underlie it, and how you go about using it. We'll talk about the events and the actual API endpoints that make up ARI. We'll look at some tools that help you get started with ARI, learn it, and explore it, discover what it can do, and do tests on applications that you're building. We'll do a Hello World application, and we'll do it two different ways. One, we'll walk through it API by API, so you can see all of the steps that go into it. And then we'll actually turn around and we'll build it again using JavaScript, since it's a relatively straightforward language that most sorts of developers know. And at the end, we'll give you a list of additional resources which can help you with ARI development. So to kind of step back for a second, if you look at Asterisk, the very first interface that was available for application development was C. Asterisk itself, like Linux, is written in C, and C is a very powerful language. And on its face, it's actually a very simple language. It's got a relatively limited vocabulary, and with that vocabulary, you can build some amazing things which run very, very close to, and in fact directly on top of, the bare metal of your computer, which makes it blazingly fast. That said, to build something as complicated and capable as Asterisk out of it requires a great deal of patience, a good knowledge of the C language, a good knowledge of all of the libraries that are available to the C language. And as Asterisk has grown, it's required a very strong knowledge of the internals of Asterisk itself. The API, the internal API of Asterisk, is extremely capable, but when exposed through C and approached directly, it's not for the faint of heart. It's actually very easy to go into the Asterisk source code and make changes, but it's just as easy to go in and introduce new bugs. And so one of the things that's been a guiding principle for the development of ARI is to make it simple for people to use all of the low-level powerful pieces within Asterisk without making it easy to introduce bugs and regressions. So if you've been around Asterisk for a while, you know that another one of the most common interfaces is the classic Diaplan. This is the scripting language that we constructed as we built Asterisk over the last 15 years. And it sort of thinks, or it operates from the perspective of an individual channel. Now, if you're not familiar with Asterisk, a channel is essentially the first-person perspective of a call arriving in. When you make a call to Asterisk from a phone, that creates a channel. And if that Asterisk instance then turns around and sends a call back out, say over a SIP trunk or over a DOTI line or something like that, then that is actually creating yet another channel. So everything that is actually a media-bearing instance within Asterisk is at its core a channel. And the Diaplan deals with things at the channel level. It is relatively simple. It's kind of an awkward, obtuse syntax, but there's nothing particularly difficult about it. And in fact, there's a lot of people who don't consider themselves developers who do a great deal of development using Diaplan and have built some rather amazing applications. But it's a bit kludgy. It is non-standard. It doesn't look like really any other language other than possibly BASIC, just a bit. It is a bit difficult to structure elegantly. You don't have the ability to use libraries and some of the other sort of typical development tools in any real way, and it's difficult to extend. If you want to build new components, new either actions, applications, or if you want to build new syntactic units, functions, or things like that, then you actually have to jump down to the C level to create those so that they're then exposed and available in the Diaplan. So that is an unfortunate and difficult challenge for some people. So that is the primary interface that, one of the primary interfaces that we're looking at being able to sort of augment with ARI. Now, another API that you're probably familiar with if you've spent any time around Asterisk is the Asterisk Gateway Interface, or AGI. Now, AGI allows you to pause execution within the Diaplan and send out to a remote process, and that remote process can be running either on the same computer as your Asterisk instance or on a separate computer, and allow that system to do some processing. It also gives you access to quote-unquote real languages, the ability to make use of libraries and connections to external databases and things that are rather difficult to do from within the Diaplan. It's nice. It allows you to offload certain types of processing from your Asterisk system, but it has a very limited view of Asterisk data. So it, like the Diaplan, is first person. It thinks in the perspective of a channel, and it doesn't have any view as to the other channels and what else is going on within your Asterisk instance. If you run your AGI program on the same system that you're running your Asterisk on, you're actually introducing additional overhead. Typically, you're firing up a separate instance of an application, and perhaps the command interpreter that goes with that, for every call that you're running through AGI. And that can add some significant overhead. In a lot of ways, AGI gets used as a wrapper around Diaplan. People don't want to necessarily have to do everything in the sort of basic style script that you can do with the Diaplan. So they choose to write things in AGI. And that adds a great deal of overhead again, and it sort of steps away from Asterisk at one level of remove, which doesn't give you access to all of the low-level functions. And it's also synchronous. So it operates one step at a time, and doesn't really have a good way of interpreting events coming from outside systems. You can kludge that, but it isn't native to it. Now, if you're looking for something that's asynchronous, the classic answer in the world of Asterisk is the Asterisk Manager Interface, or AMI. This is a system that was originally created to allow you to monitor an Asterisk system and to send commands and receive responses, so sort of call and response, using a third-person view of things. It's omniscient. It runs above all of the channels, and it's able to view what's going on throughout the system. Now, that's great for command and control, but it actually then limits you. It's very difficult to use the manager interface for doing first-person functions, for doing the sorts of channel-level functions that you need to do to process a call from step to step, to run that level of state machine. So it's got some good, aspects. It's asynchronous. It has a great view of things, but it also has some limitations. It is, not first-person friendly, and it has a very strange syntax that goes all the way back to the beginning of Asterisk. And so you have to build a custom parser or use a custom parsing library to integrate it. And even then, it's not the friendliest thing. So that's where all of these things have come from. If you ever decide you want to build a truly complex Asterisk application, and Digium has done this. We've built Switchvox, which is our commercial phone system, and we've built a number of other solutions for large-scale clients. And in every case, you wind up using all of these interfaces. You have to use the Diaplan at the very least as the entry point for calls that are coming in. You typically use AGI to take care of the first-person perspective when you need to talk to a complicated external system. And then you use AMI. I know that slide is wrong. I should have updated that after the last time. So that you're actually able to then coordinate things across channels. And that is certainly doable. We've done it. Lots of other companies have done it and built very powerful contact center solutions and large-scale switching systems for enterprises, complete residential telephony solutions. But it's not exactly ideal. And what it doesn't do is give you access. What none of these do is give you access to the low-level internals of Asterisk so that you can actually create new applications. And so that's where ARI really comes in. So here's a quick sort of Venn diagram that project leader Matt Jordan put together when he was introducing us all to the concept of ARI. On the left-hand side, you see the call control, the third-party call control of AMI. And on the right-hand side, you see Diaplan execution and first-person operations going on from either AGI or Diaplan itself. And in the middle, you see ARI. It actually covers both sides of that. It has something of a global view, and it can access global information throughout any given instance of Asterisk. But it also operates at the channel level and gives you very low-level control over each individual channel and the way that it's operating and the methods that it's using, all of which are mapped to the internal structures of Asterisk, but in a way that is relatively easy for any developer to use. It doesn't require you understand the low-level C code in order to make this happen. So the overview is, it isn't a wrapper around existing applications. It is instead a means of creating wholly new applications that replace many of the things that are part and parcel of the core Diaplan. Things like app voicemail or app queue. Some of the things that are sort of at the core of Asterisk, but may not necessarily work the way you want it to. It also opens it up for you to create completely new applications that do things that no one's ever thought of before, because you, again, have access to all of the low-level internals of Asterisk. So you have access to channels, you have access to bridges, you have access to the Asterisk configuration itself, all from a single logical programmatic API. So the technology that makes up Asterisk is kind of interesting. Now there's a Diaplan application that's been added in called Stasis. And this is where you hand off from the traditional Diaplan world into the ARI world. So this is similar to the AGI command, in fact, if you're accustomed to using that. You run through the Diaplan to the point where you need to invoke your ARI application, and then you use the stasis command to hand operations over to your ARI application. Inside your ARI application, you'll actually make use of a couple of additional components or technologies to make your application work. The first of those is the REST API itself, and we'll go through a quick review of what REST is and does. But essentially, this is the means by which you push commands to an Asterisk instance and receive responses. It's much like HTTP. It's a request-response model. Now, that's great, but there's some things that don't really model to that very well. Remember, telephony is itself inherently an asynchronous operation. You've got people hanging up channels randomly. You've got digits coming in the middle of a call. And so to properly process that, we've added an additional sort of transporter or interconnect between your application and the Asterisk instance, and that's a WebSocket interface. So your application will have to have an HTTP client to use the REST functions, and then it'll also have to have a WebSocket client to receive asynchronous events as they occur. And all of the data that's transported back and forth in this is encoded as JSON, which is about the most standard thing you can find these days. It's easier to deal with than XML, and certainly easier to deal with than the native and sort of custom format that the Asterisk Manager interface is used. So those are the four basic pillars on which the ARI is built. Now, this kind of shows you how an ARI application fits together. So over here on the right, you see Asterisk 13, and over on the left, you see your application. So coming across the top here, you say ARI commands, which are being sent over HTTP, and the responses that come back across that. Below that, though, you see where events are coming asynchronously across the WebSocket and reaching your application. Your application's job is to coordinate all of that, but because it's asynchronous, it's relatively straightforward to do this. We'll kind of talk through some of that. Now, just take a moment to recognize that while we're going to be doing a demo application in a little while using JavaScript and Node.js, that is just one of a very long list of frameworks and languages that you can use for doing ARI programming. You can write ARI applications using any language that supports the technologies that are listed there. So you have to have something that can interpret JSON. You have to have a WebSocket interface to receive events, and you have to have an HTTP client to be able to send commands and get responses. But all of that is relatively simple. That's table stakes in most common languages and frameworks. So there are already libraries built, in fact, for a number of them. There's a library that Digium has developed for JavaScript and another one for Python. Nir Siminovich from Greenfield Technologies has contributed an absolutely brilliant PHP library, which takes a language which is inherently not asynchronous, or which is inherently synchronous, and makes it work in an async world. Ruby there's a library for it. It, of course, is inherently async, so that's not a problem. C#, .NET, Java, and probably any number of other less known but still very popular and useful languages are also supported. So in order to get ARI running in your system, there are a couple of things you need to do first. Because ARI makes use of HTTP, you'll need to go in and enable the HTTP server, which is part of Asterisk. It's the same server which is used for a lot of the internal manager functions. It's used for SIP over WebSockets, for WebRTC. So it's already there. All you have to do is turn it on. You need to go in and set enabled equals yes. The bind adder, which is the bind address, you'll want to set to whatever makes sense for your system. In this case, 0.0.0.0 says all of the interfaces on this system. And the port by default is 8088. Once you've done that, you'll need to reload Asterisk to get that enabled. Then you have one more step that you have to do in the config files. You'll actually need to, oops, I have a slide out of order. Is that or I'm missing a slide? Pardon me for a second. There we go. That's odd. So here's the second step. You have to go into ARI.conf and set enabled equals yes and allowed origins equals, and in this case we have star set, which is any origin. If you're running a production system, you'll probably want to keep it very carefully firewalled away from the public internet, but at the very least you'll want to set it up so that origins are controlled so that there aren't people at random spots in your company's network sending commands to your Asterisk. You'll also need to create a user. So in classic Asterisk style, the user is created with the username in brackets, type equals user, and then you'll need to set a password, and the password format actually defaults to plain text, but you can pick from several. And the file, ARI.conf, actually is documented reasonably well, so you can see what your options are for that. And once you've turned that on, you'll need to go back down to the Asterisk command line and reload the ARI module to get all that to take. So stepping back for a second, the third step in being able to use ARI is to actually create one or more spots within your Diaplan where you use the Stasis app to invoke an ARI application. So here we see the inside context, and within there's extension 1000. The first no-op step simply echoes out to the console so you know that it's being called, passing control to an ARI app. And then the next step, Stasis, is where we pass control over to an application called Hello World. Now it's worth pointing out that you can have any number of applications, all of which are connected up to an Asterisk box, and are separated by namespaces, through the name that you see passed here. So instead of Hello World, you could have, ACD, you could have voicemail, you could have whatever you want, and that gets passed in. Also, you're allowed to put as many arguments after that as you wish. I think there may be a character string length, but it's reasonably long, so you can put a good bit of additional data in, coming from the Diaplan and being passed into your ARI application. So now, once you've got that done, you're actually ready to start using it. So let's talk a little bit about how ARI actually works. ARI is a typical REST API. On a REST API, REST stands for Representational State Transfer, and it's simply the basic and very popular format used for doing machine-to-machine or programmatic interaction using HTTP primitives. HTTP is made up of a number of primitives. The four most common are GET, which allows you to send a request and get a response. It's usually used to query information. POST, which is used to usually create a new instance of a particular object or data element. It can also be used to execute a command. PUT, which is used to update an existing data element. Or delete, which is used to remove something. Now, oftentimes these are used for the typical CRUD, C-R-U-D, create, read, update, and delete within data storage applications, but they can also be mapped to lots of different sorts of functions. So it's not simply about writing and reading data. It's also about manipulating and managing the operation of your system. So that's the basics of REST. There are huge books written about it, so I apologize if I'm glossing over many of the important parts of it. But we're already 25 minutes into this, and we've still got quite a bit to cover. So one of the neat tools that is built into the ARI system is documentation that is interactive. We've used a system called Swagger, which is both a documentation format, and it's also a means of providing testing and automated library building for REST applications. So to use Swagger, you don't even have to install anything. You can actually go to the ari.asterisk.org site, and that'll bring up the Swagger UI. From there, there's actually a couple of spots for you to fill in additional information. You can put in the URL for your asterisk, and you see it formatted here with HTTP, and then you see the red highlighted area, which is my asterisk, 10.0.1.57:8088, which is the port you're on, then /ARI, because remember, we're talking to the general purpose web server that's built into Asterisk, so we have to tell it that we're going into the ARI sort of subsection, and then API docs and resources.json, and that is built into every instance of ARI that's out there, so it is self-documented. When the Swagger the Swagger UI connects to it, it will actually pull the exact documentation for the interface that you're using from your system. So you'll have exactly what's up to date and correct there. You'll also need to provide an API key, and the API key is simply created by joining the username and the password that you set up in ari.conf with a colon in between. So username, password. Once you have that in place, there's a lot of things that you can get out of it. So it'll allow you to review all of the available API endpoints, not Asterisk endpoints, but API endpoints that are exposed by the ARI as it runs on your system. So if you, for example, update to a newer version of Asterisk and additional endpoints have been added, those will automatically show up in the documentation within the Swagger UI. It makes it easy for you to view the parameter formats, the things that you have to feed in for a particular request. It lets you test things out in real time directly. You can actually key information in and hit test it, and it will actually go out and run it against your Asterisk system. And this makes it easy to figure out what works, what doesn't, kind of puzzle your way through the intricacies of the API. Now, you won't want to do this for a production application. Of course, you'll want to actually use a library, either one of the pre-existing libraries, or if you want, you're welcome to use the Swagger library generation tools to roll your own. And I would say that it's also important to make sure you don't enable access through this on a production system. You don't want people even accidentally going in and executing direct API calls against your Asterisk if it's in production and processing calls. So here's a quick look of the Swagger UI. As you can see at the top, we have the box with our URL popped in there, and then the API key. So you put those two values in and you click Explore, and as I said, it's actually going to query your Asterisk in real time, and it will dump out all of the endpoints. And we'll walk through what you see here in just a few minutes and talk about what each one of these things does. But I'll show you another view. This is once you've actually gone and you've started making use of it. Here we see the applications endpoint within the Swagger UI. And in this case, it actually gives you the ability to, I think that the example we have is a get, where we're actually getting a list of applications that are running, or this may be getting a specific application. Unfortunately, it's very small on my screen, so it's hard to see. But it shows you the details of it, all the way down to the URL that's being invoked to request it, and then also the response that comes back from the server. And you can do this as many times as you like. You can play around with it, and it gives you a really good feel for what's going on in the API. Now, that's the command and response side of it. Now, remember, we also have events that are coming across a WebSocket. The tools for doing this sort of development aren't quite as clever as Swagger, but there's actually a utility that makes it fairly straightforward to do from the command line. So you'll open up a Linux console instance, and you'll need to install the wscat utility, which stands for WebSocket Cat, which is basically just a command line utility that allows you to monitor data that is being sent to a WebSocket. You can install that in a number of different ways, and if you want to, you can use npm install wscat. And in some cases, it's probably pre-built for various operating systems, so you'll want to perhaps use apt-get install wscat. In this case, what you see in the actual command line there is the asterisk URL again, so WebSocket : /localhost./8088 /ARI/ and then the API that we're invoking here is events. And then on the query string, you need to pass in two things. You're going to pass in your API key, which again is your username and password, and then you're also going to have another value that's separated by an ampersand there, and that is the name of the app that you want to monitor. Because again, you can have multiple applications. Each one of those applications will have its own WebSocket that is feeding data. And by the way, each application gets exactly one WebSocket right now. So something to think about when you're building an application. Don't presume that you can have one application serviced by multiple WebSockets to multiple devices. But in this case, this will give us all of the output from the Hello World app, and we're going to make use of that as we walk through. Here's an example of the data that comes across from wscat as a call arrives. And you'll see that there's a bunch of text here in JSON format that says that the application name is Hello World, that the event type is a very important value because you'll see that in almost every event that comes in, and that's how you separate out what's happening, and that is stasis start, which means that an application has been dropped into stasis. You'll also see some other information, timestamp, set of arguments. In this case, the arguments are null, but normally there would be, if you passed arguments in, those would be elements in that array that you see. Then channel. And channel is where you get some very important information. You need the channel handle, which is the ID value you see there. You also can see the channel state, which is up, which means that this particular call has already been answered. Now, if you answer it out in the Diaplan, that's normally what you'll see. If you pass an unanswered call directly into stasis, it will actually have a state value of ring. It shows the channel name and then some information about the caller, the connected party, account code, and some of the other standard asterisk-related things, including the Diaplan information related to it. I'm going to show you one more example. Here is what happens when a call receives, or a channel receives a DTMF digit from the phone that's attached to it. In this case, it occurs, again, completely asynchronously and simply arrives on the WebSocket. You see that the type here is shown as channel DTMF received, and you'll see the digit value shows 2. This makes it really, really simple to build DTMF-based applications. You can play a prompt to your caller and ask them to respond, and then you simply wait for a certain number of seconds, collecting whatever digits they enter. Straightforward, makes it easy to manage digit buffers, etc. And again, it's providing a lower level of access than what you typically have within AGI, and the Diaplan. So now that we've gone through both the API, REST function and the event function, let's take a quick look at what some of the APIs are, all of which have, of course, REST calls that you can make and events that come across. And they're all documented, by the way, on our wiki. So applications gives you an access to all of the ARI applications that are active on the system. So you're able to query a list of them and manage them, control what they're accessing. The Asterisk API gives you access to the configuration of Asterisk. You can query configuration information from it. In some cases, you can update query or configuration information into it, and you can manage log and debug state information. So you're actually able to remote control, puppet, many of the functions of the Asterisk system itself. It's not quite as robust as we'd like. There are still functions that need to be added in, but it gives you a good deal of control over the actual Asterisk instance. Now, channels are probably, again, the most important thing here, because this is where information actually flows in and out of an Asterisk system is via a channel. And this gives you the ability to create new channels, for example, for outbound calls, and also to respond to automatically created channels, which happen when an incoming call arrives. It lets you play back media, stop media that's being played back, monitor a channel, bridge channels together, all sorts of functions. In fact, most functions that you'll use to build an actual ARI application depend on the channel API. Endpoints actually refers to, in this case, not REST endpoints, but actual Asterisk endpoints. And endpoints can be SIP channels, they can be PJ SIP channels, they can be DOTI channels, they can be SIP trunks. They are any of the I/O endpoints, the defined endpoints that you'll find within the system. Endpoint is a term that's come along in the last few years and is being used prevalently in the PJ SIP channel, but it really defines simply the individual items to which an asterisk can talk. Bridges, of course, are where you actually tie together calls. Now, you can have bridges that have just one call in them, and those are holding bridges. You can play hold music to it. You can have bridges that are one-on-one, where you're actually just tying two calls together in a traditional phone call. Or you can have a bridge like we're using right now, which is a mixing bridge, where there can be multiple participants. So all of those fit together under the bridges heading, and you're able to construct bridges, add channels to them, remove channels from them, play music into them, record them, play specific prompt files into them. So you have complete control, the sort of control you normally or used to have to use the C API to get. So you can build your own conferencing application. You can build your own queuing application, all using these structures. Playbacks are created in order to manage the playback of audio. So when you play audio, you'll actually create one of these, and this allows you to be notified when the playback ends or is interrupted. Recordings are roughly the same thing, but in reverse. It's what you'll use to manage the recording of audio, either coming off of a channel or off of a bridge. Mailboxes gives you access to the mailboxes that are set up on the system if you're using the traditional app voicemail. So you can integrate between external ARI-based applications and the native voicemail system. Sounds provide the same sort of functionality for all of the sound files that are installed on the system. So you can list and review all of the sounds that are there. Device states allows you to interact with the device state and presence information system that's built into Asterisk. And the event system is what's used to create our WebSocket and provide events, and also a means by which you can generate user events, which are then sent to various destinations within the system. So those are the APIs. I wish I had more time to go through each of them in more detail, but fortunately, since I don't, the Swagger system gives you very good information about this. Plus, again, there's good documentation built into the wiki. So now we've arrived at the point where we're going to walk through using the ARI interface, but using it from a very manual perspective. I've got a number of things in here where you'll actually see the URLs that you're going to use. We're going to create a mixing bridge. It's a named bridge, so you can refer to it by name. We're going to answer an incoming call when we receive an event across the WebSocket. We're going to play a greeting to that call. We're going to place that call into a bridge, and then we're going to torture the caller with hold music. So that's what we're going to do. Now keep in mind, again, you aren't going to have to do it this way in the real world. You'll actually use a library, but it's very good to understand the underlying mechanics of the API. So the first step is to create a bridge. Now ordinarily, it says the trigger on there is the application loads. So when the application starts up, it'll create a bridge. And you'll see this again when we do this in JavaScript and Node.js. This bridge is the bridge to which we'll be adding our caller when they get in there. And we create it at the beginning, and it will exist in Asterisk until either it's removed using a removal command, a delete, or until Asterisk actually terminates. So once you've created it, it's there. Now if you try to recreate it, if you run your application again, say you stop it and restart it, and you use the same name, that will actually generate an error message, but the error message will simply tell you that you can't recreate an existing bridge. So something you can typically ignore if you already have it created. So the second step will be to answer an incoming call. So remember the big blob of JSON that we got through wscat, and that provided us indication that a call was arriving, and it gave us, among other things, the channel ID. So in order to actually take that call from the ringing state and move it into the answered state, which will signal back to the other end, hey, we're off hook, and it'll also turn off the ringing mechanism going on within Asterisk. You need to send the answer request to the API. So you'll see what we're going to do is post to the channels API. We'll pass in the channel ID value, and then we'll pass the method request answer. So you'll see in the request URL, we've got our Asterisk identifier, the IP address and port, ARI, and then we're using the channels API and pump in the channel ID that we copied from the incoming blob of JSON, and then answer, and then we'll pass in one additional piece of information, which is simply the API key, which the API uses to authenticate us, keep people who shouldn't be able to send commands from sending commands. And the effect of this will be to take the call off hook. At the same time, it's also starting the process which will wind up generating another event, which is the channel state changed event. And that is what we would use as a trigger for the next step, which is to play a greeting. So you will take the channel and you'll listen for events coming in related to that. And if you get channel state change and the resulting state shows as up, then okay, great, we know it's time to play our greeting. Now here's where there's something a little bit interesting. You'll notice in the parameters line there, it says media equals sound : hello world. This is an Asterisk specific URI. Sound : tells it that it's actually one of the onboard sounds that's built into Asterisk. And then hello-world is the name of the prompt. That prompt will probably exist in at least one and maybe more than one language within the system. And if you're aware of Asterisk and the way that it interacts with languages, normally a channel is tagged with a specific language. So it will try to use the language to which the channel has been tagged. And you can actually override that by passing in an additional language parameter if you want. This, again, is very low-level stuff compared to what's accessible from most of the other APIs within Asterisk. Now, this isn't the lowest level thing you can do. There are many other APIs which are actually more complex and probably wouldn't have fit as well on the screen. And you can discover those, again, by playing with Swagger. So in the request URL, you'll see that we're actually passing in, again, to the channels API, the channel ID, and in this time, the verb we're invoking is play. And we pass a media parameter, and that's where we use our sound URI. So sound, and then %3a is the colon encoded for the web. Hello world, and then we pass our API key again. As soon as you hit enter on that, or hit test it, it will actually invoke it. So if you had the channel sitting there waiting for you, you'll suddenly hear Allison's voice say, hello world. That will start a playback, and then the playback will come to an end as soon as it reaches the end. And we can use that playback ended mechanism or event as the notice that it's time to go to the next step. So go to the next slide here. There we go. And that is to place the call into the bridge. So you see, trigger there is playback finished. And this time we're going to use the bridge API rather than the channel API. And we'll post to bridges, and we'll pass in our bridge ID that we created in that very first step where we created the bridge. And then we'll use the add channel method, and we'll pass in parameters, and that's going to be the channel ID. So if you look here, you'll see in the request URL, here's our bridges, and we named that bridge we created HW bridge, for Hello World Bridge, and then add channel, channel equals, and then the channel ID, and then API key again. Each function you call will actually require that API key. That will move the channel into the bridge. Now the caller won't notice any difference because there's nothing else in the bridge at the time, but we can easily add music on hold to that bridge. So the next and final step in this walkthrough, we'll actually use the bridge's MOH, or music on hold method, to turn on music on hold. And here you see again, we're going to call the bridges API, HW bridge is the bridge we're working on, and MOH is the command. And again, all we need is the API key at that point, and it will start music on hold playing, and I'm sure the people in the bridge will just really appreciate that, because everybody loves music on hold. So that's the basics of walking through it step by step. Now the next thing that we're going to do is actually walk through the same thing, but using an actual language. We're going to use Node.js again because it's pretty common. Most everybody knows either JavaScript or some kind of curly brace language if they're a developer. So it should be relatively straightforward to pick up. So to get started to do this, of course, you'll need to have Node.js and the Node Package Management, or NPM, library installed on your computer. You can simply create a directory, change directory into it, npm init to actually start the application process building to actually create. There's a packages.json file that gets initialized, and then you'll use npm install to install the ARI-client library, because we're going to actually use that instead of using raw HTTP commands, because frankly it's a whole lot easier. So the next step here, you'll actually see, we'll walk through, there's roughly 3 screens to the application. It works out to maybe 50 or 60 lines of code total, and it's all pretty simple. In the very top here, you see we create a client variable, excuse me, and in that case we require the ARI client library. That's getting us a handle to the library. It is unconnected to anything at that point. The next line is where we actually connect that to the Asterisk system that we want to control. And so we pass in the URL for the Asterisk, the username and password, and then the function to be called when that asynchronous connection request is completed. So the callback for it. You'll see the callback is called loaded, and the function loaded right below there. You see there's 2 parameters that are passed to it. The first one is an error, and the next one is ARI, which is the handle to an ARI control object. Now, this is a fairly standard syntax for Node.js JavaScript, and typically, if everything goes well, that error parameter will be null, so there won't be anything in it. You see, we check that first, and if there actually is a value in it, if error exists, then we throw the error and everything ends. But if it doesn't, we continue on. And the first thing that we do is we create a callback for the stasis start event. Remember that event that we got at the very beginning, which indicates that a call has been delivered to stasis? Well, we're hooking it, and we're saying that when any of those events arrive, pass it off to a function, a callback function, called channel joined. Now, for those of you who are actual full-time Node.js programmers, be aware that this actually works just as well with promises as well as with legacy callbacks. So you don't have to build the infinitely deep callback chain of yore. You can actually build it in a much more modern way. But for this simple application, it's probably easiest to show it with the callback. So here's our function, channel joined, and it has 2 parameters. When the event comes in, it will receive the event itself. So all of that data that you saw represented as JSON in the wscat session, and then a handle to the channel object that you can use to access any of the channel-related variables. Now, the first thing that we do is for that channel, we actually hook an event for it. So the channel state change event, and that happens. We do that so that we know when the channel goes from ringing to up. So we're ready to actually play back to it. Again, we're sort of setting up a series of triggers, as you saw in the last set of slides. We're just doing it programmatically rather than manually. So then we call the channel.answer method, and we pass in a callback function there, which just looks for an error. And if an error happens, then we throw it and we blow everything up. Typically, if everything's working right, though, that won't happen. What will happen is the channel changed event will get called when the channel changes its state. Remember, it starts out in ring. When it goes to a different state, this will get called, and it'll check the actual state value. And if that state value is listed as up, then it's going to play a file. And here you again see our sound : hello world over this channel. And then it's going to set another callback, which is add to bridge, so that as soon as it gets done with the playback piece, it then goes on to the add to bridge function. Down here you see function play, where it takes the channel as a parameter, and then the sound value as a parameter, and the callback as a parameter. So we create a playback object that's empty to begin with, and then we actually, for that playback, set a handler for the playback finished event, so that when that playback finished event occurs, we know then to go on and invoke the callback, which, if you'll recall, the callback is to push it on to add to bridge. and then we actually execute the play, passing in the media value, and we check for, or we actually have a null function there that would ordinarily check for errors, but we decided to be a little bit brief in this. So when the playback starts, your application sits idle until it gets the next event. When that event comes in and it's playback finished, then that tells this to call the callback, passing the channel value so that the channel goes on to the next function that receives it. So here we see the add to bridge function, which receives that channel, and it uses the bridge.addChannel method. Now remember add channel from when we were doing it manually. In this case, it's simply part of a bridge. Now you're going, where did that bridge object came from? Well, you'll see at the very bottom of this, in fact, right down below here, where we create that. That actually happens in the initialization or the launch of the application. And syntactically, it just works best to put it at the bottom so you can kind of see, oh, it goes through all of this initialization process. Then it invokes the creation of the bridge. And then once the bridge has been created successfully, it actually uses the ARI.start method to register to handle requests that come into Hello World. So again, when a call comes into Hello World, the first thing it's going to do is hit the status start event. The status start event will trigger us to answer the call. Once the state change for that channel jumps to up, then we'll actually be able to play audio to it. So we jump into the play function. When the play function completes, you'll actually get another event for playback complete. When that happens, then you pass the channel over to another function, which puts it into the bridge. And you'll see here in the add to bridge, the last step after it's checked for error is to bridge.startMOH, which is where we start torturing people with our lovely hold music. So that's the basics of it. Now, I figure if you're going to put people in there, it might be useful for them to be able to do something other than just listen to hold music, since, well, that's kind of a useless application. So what if you had a second call come in, and when you had two people in the bridge, then the hold music went away and they were able to talk to each other? Because remember, we created a mixing bridge here. You're actually able to use it for regular communication. And if you have 3 or 4 or 5 people, they all can jump in, just the way you would in a conf bridge, because this is actually the underlying structures which make up conf bridge. Excuse me. So to do that, we actually hook an additional event. So on status end, we're actually going to call a function called channel left. And in channel left, we get the event in the channel, just like we did on channel joined. We're going to then go to the bridge, and we're going to use the bridge.get function to get all of the current details about that bridge, including a list of participants in it. Now, the list of participants shows up as channels, and that is an array, and an array value in JavaScript has a length, so we use details.channels.length to see if the number of participants in there is equal to 1. And if it's exactly 1, then we start music on hold. Now, we'll go on and make another change over here. We'll modify our add to bridge method or function that we set up. And when we call that, in this case, we'll still add the channel to the bridge just like we did before. But then afterwards, we will again use bridge.get to request the current bridge status, get the bridge details. And when that arrives, we will again check the length. And if it's equal to 1, then we know, hey, okay, start music on hold. But if it's equal to 2, if there's more than 1 in there, then we're going to actually stop music on hold. Now, there are several ways you could go about doing this. This may not necessarily be the most elegant, and certainly it replicates the functions of an existing system, which is confbridge. But it shows you that you actually have access to the primitives that make up Asterisk, all of the core level functions that have up to this point only been accessible through C. So you're able to build some incredibly powerful functions without delving into the C API. You're able to do it using basically web languages, scripting languages, but these have access to a much broader and richer set of data and state and control than you ever had for many of the existing APIs. Now, we used JavaScript for this example, and I was really hoping to be able to show a Python example and a PHP example, but I found out that I talk too much, and it doesn't actually all fit into this one webinar. But I will remind you that you can do that You can build it from Python, PHP, .NET, any of these other languages, and it's going to operate exactly the same. You'll still be listening for events. You'll still be responding to events. You'll still be making use of REST calls to reach out and tell Asterisk what to do and receive responses. Typically the sort of response you normally would get from a web API, 200 OK, 500 server error, that sort of thing. So very simple and accessible to a very, very broad set of language platforms. So that kind of covers all of the basics. I will point out that there are a number of additional resources that you might want to check if you're interested in going further with ARI, and I hope you are. The Asterisk Wiki is actually where the reference for this is. And we'll be sending around an email that includes this information, but it'll be a day or so before you get it. So it's probably worth noting if you were interested in looking today. Go to wiki.asterisk.org, and you can find out a great deal more about ARI, including all of the sort of command reference. Of course, if you set it up and start using it from your Asterisk, you can check that out from Swagger. Also, we have a GitHub account that has a number of sample applications in it, including a very full-featured app voicemail replacement that we wrote as an initial sort of proof of concept to prove that you actually could build a rich, low-level application using, in this case, I think it's built in Node.js as well. There are also examples there in Python, and I believe that there are some references to other libraries that you can use and other sample code that you can look at if you happen to prefer PHP or .NET or something. Also, we have a YouTube channel which has a large number of videos in it, and these are covering a lot of topics, but there are a number of different videos that talk about ARI, both from the technical low-level perspective and also from the sort of higher level, why this was useful to my business. So if you want to justify something to your manager, there's probably good information in there as well. So that brings me to the end of the formal presentation. I have one more poll question, and I'd like to know a little bit about the background. Actually, I have two more poll questions, but this is the last one that's going to be shown to everybody. If you're a systems administrator, we'd like to know that. If you're a web developer, let us know. If you're a full-stack developer working across a number of different technologies, that's great. A low-level or embedded systems developer, a manager for developers, or not a developer at all, please let us know, and we'd appreciate it. So 3 and 2 and 1. Okay, and let's take a quick look at what we got. Looks like a fair number of sysadmins, a fair number of full-stack developers, a few web devs, a very few embedded folk, some managers, and some non-developers answer that question. All right. Very good. And finally, in order to figure out where we can go to help you move forward on this, last question is, what can we do next? So if you'd like some assistance with an Asterisk project, let us know, and we can put you in touch with somebody who's an expert at it. If you need additional hardware, if you need phones or any of the things that Digium offers that I mentioned at the beginning, cards, gateways, support, training, let us know about that. If you'd like to talk to somebody who's a local reseller in your area about purchasing Asterisk-related equipment, that's great. If you'd like to become a reseller, let us know, and I'll hand you over to our recruiting folk. And if you're just researching, let us know so we don't pester you with anything. I mean, we don't intend to spam anybody, but we do want to keep in touch with everybody and help you move forward with your projects. So if you could, take just a moment to answer that. 3, 2, 1. Thank you. Well, that's the end of this webinar, and unfortunately, I'm both out of time and my throat is starting to bug me crazy, so I apologize. We will do our best to answer questions in a follow-up email that we'll be sending out within the next few days. I appreciate everybody's time in joining us today. I hope that you're able to move forward with ARI, and I will take just a quick moment to answer. We've got a very few questions here, so. It requires Asterisk 13 or higher. It actually started in Asterisk 12, but 13 is certainly the most stable version to try and use. 12 was a non-LTS version. Let's see, how stable will this interface remain? I asked based on experience with AMI. Our intention is to make this much more stable and to properly version control it so that if we do ever make breaking changes, they will be made in the form of a new version of the API rather than simply changing the existing API out from underneath you. We understand that that's a difficulty. I don't know whether HTTPS is supported at this point. Somebody asked if it's supported. I certainly hope so, but I'm not positive about that. Can PHP work along with Node.js? Yes. There's a great PHP library for this. It's just called PHP ARI, and it's by Greenfield Technologies near Seminovich. And there's actually a couple of videos showing you how to use it in our YouTube channel. It gets a lot of support, and it's got an active community of its own. So please, if you're a PHP developer, feel free to dig into that one. It's a great library. Will this webinar happen again soon? I showed up late. We're actually running it again. It will be at 8 o'clock Central, which I believe is GMT -5 right now, this evening. And this whole thing is being recorded, and will be we'll send out a link to the recording in the email. So if you're interested in watching it again or sharing it with colleagues, you'll be able to do so. Well, folks, I'm now over a minute over, so I need to let you go. But thank you very much for attending. We appreciate your time and your interest, and we hope you enjoy working with Asterisk and with ARI. And with that, I will say have a great day. Thanks again.